So the commutative and associative properties of mathematical problems or mathematical operations. So if we take, for example, let's look at a concrete example. So if we take addition and multiplication, and if we look at a specific example, so let's say we had something like this. So 3 plus 5, okay? So 3 plus 5 is equal to 5 plus 3. So in other words, it doesn't matter which way you add these together, you're going to get the same value. So 3 plus 5 is 8, and that's equal to 5 plus 3, which is also 8. Similarly, if I was to take, for example, 3 multiplied by 5 to 5 multiplied by 3. So 3 by 5 is 15. So 3 by 5 is 15. And 5 by 3 is also 15. So what we can say then about addition and multiplication, they both are what are known as they are commutative. Okay, so addition and multiplication are commutative. Now if we look at these same examples and we change the operations and we look at subtraction or minus and multiplication, and again if we look at the same examples, so if I was to take let's say 3 minus 5, it's not equal to 5 minus 3. So it doesn't matter which way you do addition and multiplication, okay, because they have this what's known as a commutative property, but it does matter in relation to subtraction and division, should I say, not multiplication. So for example, 3 minus 5, that's equal to minus 2, and minus 2 is not equal to 5 minus 3, which is equal to plus 2 or positive 2. Okay, so they're not equal. So it does matter which way you subtract numbers from each other, because you'll get completely different properties. Likewise with division as well. So if I was to take, let's say, 3 divided by 5, 3 divided by 5 is not equal to 5 divided by 3. So if I take the example 3 divided by 5, so 3 divided by 5, that's equal to 0.6. So that's 0.6, and 0.6 is not equal to 5 divided by 3. So 5 divided by 3, which is equal to let's say 1.67. So 1.67. So what we can say about subtraction and division, they are not commutative. Okay, so they're not commutative. So it does matter which way. So for example, the way that you subtract and divide numbers in relation to each other has a significant impact on the answer that you're going to get. Whereas if you take addition and multiplication, it doesn't matter which way you add the numbers, as we've seen with these examples, or multiplied it by the numbers, they will give you the same value. So they have this what's known as a commutative property, and subtraction and division are not commutative, because it doesn't matter which way you divide and subtract numbers, you will get completely different answers. So these are very important properties when it comes to carrying out arithmetic and carrying out particular problems. So the way that you carry out the problems, depending on the operations that are at play, will have a big impact on the answer that you get. The next thing I want to look at then is this, what's known as this associative property. So again, we look at some examples. So if I was to take, let's say, So 3 plus 5 plus 3. Okay, so again we're looking at addition. First of all, addition and multiplication. So if I was to introduce brackets, so let's say, so 3 plus 5 is equal, change back to this, is equal to 3 plus 5 plus 3. Now let's say I was to introduce brackets. So remember, wherever I put brackets around, those operations have to be carried out first. So if I was to put brackets here like this, okay, so 3 plus 5 is equal to 5 plus 3. So again, if I was to work this problem out, so for example, 3 plus 5, that's equal to 8 plus 3, and this is going to be equal to 3 plus 8, and then if I add these together, I'm going to get 11 is equal to 11. So what we can say then is that addition is associative. So for example, it doesn't matter if I have like an arithmetic sequence like this, it doesn't matter which way I carry out the addition. So I can add these two numbers together first and then add this, or I can add these two together first and then add this. I'm going to get the same answer. Likewise with multiplication as well. So let me just move this up a little bit. So if I was to take, for example, 3 multiplied by 5 multiplied by 3 is equal to 3 multiplied by 5 multiplied by 3. And again, if I was to put in my brackets, let's say I was to do this part first, and in this one I was to do this part first, okay, they're still going to be equal to each other. So 3 by 5 is 15 multiplied by 3 is equal to 3 multiplied by 15. And 15 and 15 is 30, and then another 15 is 45, so that's equal to 45, and that's equal to 45. So again, what we can say then with multiplication, it is associative. So in other words, it doesn't matter which way you start, which numbers you group together and multiply first, you're still going to get the same answer with multiplication, and the same with addition as well. And likewise, if I was to do the same then with, let's say, subtraction and division. Okay, so I carry out the same kind of operation, or operations should I say. So again, if we were to do something like this, and let's stick with red, so let's say if I was to say 3 minus 5 minus 3 equals 3 minus 5 minus 3. Okay, so if I was to work out this problem, and let's say I was to put my brackets around this like this, and then I was to do these here first. So again, these are not going to be equal to each other. So 3 minus 5, that's going to give me minus 2, and then minus 3, and this is going to give me 3 minus 8. Okay, so minus 5 minus 3 is equal to minus 8. And if I subtract these from each other, so minus 2 minus 3 will leave you on minus 5, and 3 minus 8 so 3 minus 2, that's going to be equal to 3 minus 2 is 1. So we can see that these are not equal to each other. And likewise, if I was to do 3 divided by 5 divided by 3 equals 3 divided by 5 divided by 3. So again, let's say if I was to do this one first in the first operation and then do this one second in the next operation. So if I take, so for example, 3 divided by 5, so 3 divided by 5, let me just clear this, so 3 divided by 5, that's equal to 0.6, so that's going to be 0.6 divided by 3, and then we're going to have here, so 3 divided by 5 divided by 3, so 5 divided by 3, 5 divided by 3 is equal to 1. We'll just say, let's say 1.6, so 1.67. So we can see that these are not going to be equal to each other. So 0.6 divided by 3, so 0.6 divided by 3 is equal to 0.2, so that's equal to 0.2 is not equal to so 3 divided by 1.67, which is equal to let's say 1.8, round it up to 1.8, so 1.8. So we can see that these are not equal to each other. So again, what we can say is that subtraction and division are not associative. Okay, so they're not associative. So these are like they're important properties to consider when you're carrying out arithmetic and when you're carrying out problems. So kind of to like cap or summarize it, when we're adding and multiplying numbers, it doesn't matter which way we add or multiply them, and we're going to end up with the same number. So therefore they're what are known as commutative. If we take subtraction and division, it does matter which way we divide or subtract numbers from each other, because subtraction and division are what are known as commutative. It does have, you'll end up with completely different answers. Likewise then as well, if we have a group of numbers that we're adding together, doesn't matter which way we group them or add them together, we'll end up with the same number. Same with multiplication, and that's because they're associative. Whereas if we take, let's say, a group of numbers that we're subtracting from each other or dividing by each other, it does matter which way you group them, because you're going to end up with two different answers depending on the way that you group them or the parts that you do first, like we've done here with the examples. So that is the commutative and associative properties of addition, subtraction, multiplication, and division.